In this lesson we're going to look at displacement reactions between the halogens. So to start off with here, we've got three aqueous solutions of halogen salts. So for example, here we have potassium chloride solution, we'll put AQ for aqueous. We have potassium bromide solution and potassium iodide. And you'll notice that they're all colourless, transparent solutions. They look just like water to the eye. Okay, but they have the potassium salts dissolved in them. So what we're going to do is we're going to compare what happens to each solution when we add various halogen gases to each solution. Now we can't add the halogen gases directly, so what we do is we add solutions of the halogen gas dissolved in water. For example, we'll add chlorine water, that's chlorine gas dissolved in water. We'll add bromine water, again that's bromine dissolved in water. And finally we'll add iodine water to each solution, and we'll see what changes take place. Okay, so we have the three solutions here at the top of the table. So first of all we'll add chlorine water, which is also known as bleach. We'll just write, that there, commonly known as bleach. Bleach is really a solution of chlorine water. And we'll add that to the potassium chloride. We'll see that there is no change at all in the solution. There is no reaction that takes place there, so we'll put a cross there. But when we add the chlorine water to the potassium bromide, we'll see that a reaction does take place and the solution changes colour. So we get this orangey colour appearing as bromine is displaced from the solution. And then when we add chlorine water to the potassium iodide, a reaction takes place as iodine is displaced from the solution, so we get this kind of browny, darker browny colour solution. Okay, next we're going to observe the reaction with bromine water, and bromine water has an orangey, yellowy sort of colour, a bit like that. And first we're going to add it to the potassium chloride solution. Well, that's going to change colour because we're adding the bromine water to the solution, but no reaction will take place to this solution. It just adopts the colour of the bromine water. Likewise with potassium bromide, no reaction takes place there, but with potassium iodide a reaction does take place. Again, as with the chlorine water, the potassium iodide changes to a darker brown colour as iodine is displaced into the solution. So we have no reaction and no reaction. And finally we're going to add iodine water to each solution, and again this is a kind of lighter brown sort of colour, and when we add that to the potassium chloride, well, no obvious reaction takes place, the colour remains unchanged. The same with potassium bromide, no reaction, and also with potassium iodide, no reaction takes place. So we have no reaction, no reaction, and no reaction. So we're going to explain these reactions in terms of the reactivity of the halogens. We remember that the halogens start off in terms of the most reactive. We have fluorine, and then chlorine, and then bromine, and then iodine. Now, and you'll notice that a halogen is displaced from its solution by a more reactive halogen. So the reactivity increases as we move up the group, and that a halogen is displaced from its salt solution only by a more reactive halogen. So chlorine water will displace bromine ions and iodine ions from their solution, but it cannot displace, for example, fluorine ions from its solution. Likewise, bromine in bromine water will displace iodide ions from their solution, but they cannot displace chlorine ions from its solution because chlorine is more reactive than bromine, and iodine in iodine water cannot displace either bromide ions or chloride ions from their solution because it is less reactive than either of these. So let's summarise this by saying that a halogen gas will only displace a less reactive halogen ion from its salt. it cannot displace a more reactive halogen ion. Just to emphasize again here, we're not actually adding the gas directly to these solutions because the halogen gases are very dangerous indeed. They need to be dissolved in water, which makes them somewhat safer, and then these solutions are added to the salt solutions. Now then, I'd like to look a little bit more closely at these reactions to look at what's going on, and we're going to take, for example, the reaction of chlorine water with potassium bromide solution. Okay, remember that when we add the chlorine water to the potassium bromide, we get a yellow solution appearing as bromine is displaced into the solution. Let's look at the reaction. So we have chlorine plus potassium bromide produces bromine, and that's what changes the colour of the solution, plus potassium chloride. So what happens then is the chlorine kicks the bromine out of this solution and joins on with the potassium to form the potassium chloride aqueous solution. Now what's happening with the ions? This is the important thing. So let's remember that the potassium bromide solution consists of potassium ions and bromide ions in solution. So the potassium ions remain unchanged in this case, but it is the bromide ions that are going to be displaced. So we can write Cl2 plus the bromide ions produces Br2 plus Cl minus. Now to balance that, we've got two Cls, we've got Cl2 here, so we need to put 2 there, and Br2 here, so we need to put 2 there to balance the equation. So let's have a look at what's happening here. We can see that each chlorine atom in the chlorine molecule gains an electron from 2 bromide ions to form 2 chloride ions. So we say that the chlorine atom gains an electron, and when an element gains an electron, we say that it is reduced. So chlorine is reduced, and we say that the bromine is a reducing agent. And likewise we say in this reaction that the bromide ion loses an electron, and that means that it is oxidized, and we say that the chlorine gas is an oxidizing agent.